spin only formula. The main theme of this formula is to calculation of magnetic moment by the expression. Okay, so first, if we see the magnetic moment, the spin motion and the orbit motion of the electron are the sources of magnetic moment, right? That means if an electron revolves around its own axis, it will produces the spin angular momentum capital S. If the electron revolves around the nucleus, it produces orbital angular momentum capital L. This S and L are the sources to calculate the magnetic moment mu S plus L. So mu S plus L will expressed as square root of 4 S into S plus 1 L into L plus 1. But in several complexes, orbital angular momentum L can be neglected. That means the quenching of orbital angular momentum will be takes place. In those cases, we considering the expression to calculate the magnetic moment is mu S equals to square root of 4 into S plus 1, because we neglecting here the capital L, right? So we taking only spin angular momentum. So where S is n by 2, where n is number of unpaired electrons, right? So by substituting the S value, we will get the expression as mu S equals to square root of n into n plus 2. It is called as spin only formula. If we see example, hexafluorocobaltate. So it's a high spin complex. Cobalt is in +3 oxidation state. It is D6 system and number of unpaired electrons are 4. So mu S formula is mu S equals to spin only formula n into n plus 2, right? So in n plus, we be substituting number of unpaired electrons 4. So it is square root of 24. It will results the magnetic moment is 4.9 bm. Okay. Here, if we can see, if number of electrons n equals to 1, the resultant mu s value will be 1.73 bm. If number of electrons are 2, mu s value will be 2.83 bm. If n is equal to 3, mu s value will be 3.87 bm. If n is 4, mu s will be 4.9 bm. If n is 5, mu s will be 5.2 bm. So, by remembering the spin only formula, it is easy to describe the magnetic moment values for the complexes.